Great, awesome. Okay, so we're going to get started, and because I'm not listed as a speaker, I am going to say 3 things to begin this whole thing, because I'm mad that I'm not listed as a speaker, just as a moderator. And then I'm going to hand it over to Chris and then to Brandon. When you build complex systems, there are several different ways that they can be complex. They can be complex because they have multiple components. They can be complex because the components that are in them do multiple computations. The biggest thing that you need to realize when troubleshooting is that the simpler the system is, the easier it is to troubleshoot. So the number one thing that I could say is when you're building a system, you want to keep it simple. KISS. Keep it simple. That way, when you're troubleshooting the system, you don't have to go look at 2,000 components. Maybe you're looking at 10 instead of 20. And if you do the planning to have only the 10 components, then you don't have to worry about, 20 different possible places where you might be going wrong. That's the first thing. The second thing is to know, the first thing that you should know is your signal path. It's really important. And who understands what I mean when I say signal path? Okay, so just for, everybody gets it. But signal path is source to destination. So you start at your source and you get to your destination. Sometimes you work backwards, destination to source. The problem is you need to know everything in your signal path between your source and your destination. Every piece of hardware, every cable, every process in your signal path is a possible troubleshooting situation. So a lot of us in here do phased implementations, right? And we'll say, okay, we're going to do this HD build in 3 phases. And we're going to start with cameras, and then we're going to do the switcher, and then we're going to do something else. The problem with that is what we end up doing is we end up converting a lot. Every time you convert something, you're adding another thing into the signal path that can go wrong. I mean, instead of having a single SDI cable running from your camera to your switcher, you have your camera and a converter, and then a cable, and then another cable, and then your switcher, and then, a router maybe. And every one of those 4 things I just mentioned is a possible problem. And this is what, going back to the first point, keeping it simple is so important because if you just have the camera to the switcher, how many possible troubleshooting spots are there? 3 total. Okay, easier to troubleshoot that than something with 4 or 5 different paths in it. And then the third point is when you're building a system, planning is the most important thing. Probably I would probably say 50% of my time planning a system, 25% of my time implementing a system, and then another 25% troubleshooting it or debugging it or testing it. And the reason for that is I don't have to do it again. Because usually when I did it the first time, it took me a long time in the first place. And I spent a lot of money to do that system. So I need to plan it. Because when I go to my executive director with, I need $170,000. The first thing she's going to say is, what? And she laughs, right. And then she says, why? And if I planned well, I can say, this is why I need it. Okay, so when thinking about troubleshooting, if you plan correctly and then you budget based on the fact that this system that you've designed has minimal staff, staff intervention. Minimal staff intervention in your system, that's a build. That's a positive thing in your build. If you can say that this system has minimal staff intervention, automatically, it's almost like the capital door is like open to you because you're not expending operating costs. And here in California, that's super important. If I'm spending $40,000 in operating costs, that's worse than if I spent $80,000 in capital, because I've got the capital. I don't have the operating costs. So when you're designing systems, assume that you don't have the time to troubleshoot. Also assume that you don't have the staff. I mean, I don't. It's me, and then 2 other people, 1 at each station for me, who tell me what all the problems are. And if I get an email from them, that means I have to drive to either Santa Cruz or Gilroy to troubleshoot a problem. The less emails I get, the less staff time I'm expending on that problem. And honestly, if I can say I'm going to cut my staff time by 40%, I get more capital dollars to deal with that solution. So those are my things from the field, and now I'll turn it over to Chris.
Great, thanks, Nick. Thanks for being here, everyone. Obviously, you've probably been watching the diagram over my left shoulder. I've got a couple tongue-in-cheek sort of diagrams for troubleshooting, and this being one of them. I will never forget this. I found this underneath my grandfather's desk blotter, and this was his joke because he flew aircraft, so that makes it even funnier. And then I have another one. Recently, I was in an engineer's office at a public television station, and this is what I found. So, does it move? No. Should it? No. No problem. But yes, go get the WD-40. If it should move and it's not supposed to, then get the duct tape. And this is only just to say that, it's sometimes very, very simple to find a solution to problems. And you don't actually have to go to the end of the earth before you actually make sure that it's plugged in. So the first thing that you really want to make sure when you're troubleshooting any system is that it's plugged in and powered on. And I have received phone calls at 2 o'clock in the morning from customers, and they go something like this. Yes. And they respond, our system's black. I can't figure out what's going on. Okay. Well, is the server on? No, we lost power about 20 minutes ago. And that's a real phone call. So some of these things you have to sort of look at the bigger picture because there's environmental factors that come into play. We lost power to the building. Gee, that means the server's going to power off in about 5 minutes because I have no battery backup. Or my battery backup's going to run out and we don't have a generator. So definitely something to be cognizant of is that there could be higher level things at work here. And echoing some of what Nick was saying, the best kind of troubleshooting is not having to troubleshoot. And that comes from buying quality equipment that comes with service plans, and buying the tools to service that equipment when you buy the equipment. So for example, if you're going to go out and install fiber optic cables for your network or fiber optic cables to connect your cameras back to the CCUs, you need to have a fiber optic cleaning kit. It's a $350 expense, but if that fiber ever gets dirty, because it only takes one fleck of dust to kill that fiber, you can't just blow on it. You actually need a professional cleaning kit. So having that at hand and purchasing it when you purchase the rest of the equipment is very, very important. Same thing goes for making cables. If you need to make BNC cables or test BNC cables, have a BNC cable tester and a BNC cable kit. And buy those when you're actually installing the system so that you have the tools at hand, because there's nothing worse than going, well, sorry guys, the fiber's dirty, I don't have a way to clean it. And you can't exactly use Kleenex. And you can't blow on a fiber either, for example, because 1/10,000th the width of a human hair can kill something like 50% of a fiber throughput. And with digital, it's either there or it's not. So there's not quite that, well, it's sort of fuzzy, it'll work for now. Because in this new world, it's going to work or it's not going to work. There's not generally degrees in between there. It's black or white. So as I started out, you want to determine what the high-level issue is with any sort of troubleshooting workflow. The Wi-Fi doesn't work. Okay, well, that's the high-level issue. And then you want to be able to drill down in there. Maybe it's the DHCP servers and handing out addresses. So it's not all Wi-Fi is not working. It's just new people coming onto the network. Or it's the Wi-Fi is not working, but it only doesn't work when somebody uses the microwave. True story. Somebody turns the microwave on at home, all of a sudden, what the heck? my Wi-Fi is not working. You know, so there's environmental factors there that you have to look at as well. And then you can start to get more specific. One point that I'd really like to make is that it's almost never the cables. In a permanent install in your facility, 9 times out of 10, 99 times out of 100, it's never ever going to be the cable. Most people go, oh, well, I'm going to check the cable and make sure that's right. Well, if nobody touched it, don't touch it, then it's not going to be the cable. In mobile, portable field installations, it's almost always the cable. So if you're dragging cables to the field through the muck, they're getting run over by vehicles, it's almost always the cable that fails. So you've got this duality where if you're troubleshooting something in the facility, the cable is the last thing I check. If I'm troubleshooting something in the field, the cables are going to be the first thing that I'll look at. The other point, which is something Nick touched on, is document the crap out of everything. Use Google Documents, use Evernote. These are great utilities. The best part about Google Documents is that you can share them. So when I'm documenting a network, I will build the entire network in Google Docs, and I will send my customer the Google Doc. And then as the customer adds things, so Nick and I have a Google document for Santa Cruz, and as Nick adds things to the Santa Cruz network, I can watch the updates in Google Documents. So if there's a problem, I can launch Google Docs, get right in there. Okay, well he added these 3 devices, he's talking about this one, that's its IP address, this is the username and password, and I'm into the system. So getting to that level where you have all of the documentation in one place is very, very important. And having that documentation, period, is also very important. Most of these things now, devices come with like PDF manuals of some sorts. Having that PDF manual in one central location, either on a network share or even better in Google Docs so that you can access it on any device. You have the ability to upload all those PDFs and then you can dynamically access them. So if you're looking for the manual for your router that's 25,000 pages and you have to log into the Zywall account in order to get to the support page, to get to the manual, because otherwise you just have the cut sheet, having that available to you is very, very important.
On that note, we actually, at the station I work at part-time, we also use a Dropbox account for that. So all the different, basically at each of our different studios, there's a machine that has the Dropbox account set up on it, and there's just a manuals folder on the desktop, and it's all synchronized. So when I put in a new manual for a CCU, it's just there on all the systems right away.
Right, and being able to get to that very quickly, you know, because I mean, troubleshooting isn't just about finding the solution, it's about finding the right solution quickly. And Nick has 40 million other things to do than figure out why somebody's Wi-Fi isn't working. So if it's actually the access point or it's something on the network, having all of that documented in a spot where you can go look at it very quickly and rapidly and go, oh, okay, well it's this, this, and this, and draw conclusions in a very rapid manner will get you back to what you're supposed to be doing.
By the way, just on that note, it also helps, like let's say you can't be there, let's say you're not there and you have a user level problem. If you have things documented and you can send out the documentation, you can have the user troubleshoot their own problem. What a novel idea, folks. I mean, I don't have to show up for every time somebody doesn't know how to print. I can just say the print driver is right there. Try reinstalling it. And honestly, that's okay. I mean, just because you get paid as the station technician, that doesn't mean you have to show up for every user level problem. Especially because they should have tried 3 of the things that Chris talked about already before calling you. Okay, anyway, thank you.
You know, some of the other tools, I mean, there's systems in facilities that everything else rides on, right? So you've got your network, for example, and your data network is probably the most integral part of any sort of overall arching system. Because if you can't get to your data network, you might not be able to access your video server, which means you can't troubleshoot the video server using the web interface. Or if you plug, you know, I mean, having one of the best little tools I have is called a crash cart adapter. It's a $499 little device that I can plug into my laptop, and it's got a VGA cable and a USB. And I can walk through a facility, and I can plug it into any machine in the facility to the back of it, and get the console right there. I actually travel with it. TSA doesn't know what this is, and I get asked every single time. Very, very simple, you know, and having this utility means that I don't have to lug around a keyboard, monitor, and mouse if I have to plug into the back of the server somewhere. I can just pull it out of my bag and away I go. So having the tools at hand is again very important. when troubleshooting networks, and then we'll sort of talk about some of the other facets of troubleshooting. When troubleshooting networks, the tools that I tend to use are all built into my computer already. Ping is probably one of the most important tools, and it really gives you a quick baseline, is it there? So what ping is it's sort of like sonar. It goes out on the network and bounces off the server that you're trying to get to, and then comes back and tells you whether or not it's there. So if I go to a terminal here, I can go, it's kind of tiny. I can ping google.com, and you can see the response is coming back from google.com. But if I spell Google wrong, you can see I'm getting these empty packets coming back. So google.com doesn't actually exist. So this is a quick way to verify that something's there or not there. Very much like ping, there's an application called Fing, F-I-N-G. It is the most useful little utility because what it does is it goes out on the network and basically builds a list of everything, every device that responds to ping on your network. So if I run a Fing, what it's actually going to do right now is it's going on the Wi-Fi on the hotel, and it's responding back with every device that's responding to ping and their respective IP address. So in this case, I mean, there's thousands of them. But on your network, there's not going to be quite as many. So if you're looking for something, or a new workstation, or a new server, or you're not sure whether or not something's changed, it'll even return what the manufacturer of the NIC card was. So for example, Telvue, we use Supermicro chassis, so Telvue servers respond back as being Supermicro. If you're using a Netgear firewall or something like that, it'll come up with Netgear as being the owner of that MAC address.
One thing to interject in real quick, Chris. The other thing with Fing is that there's an iPhone app, which is awesome, and it's free. So that instead of you can get your laptop out, you can go quickly at a glance do the same diagnostics.
Yeah, and Fing has then rolled their platform into something that they call Fingbox. And it's sort of like a proactive troubleshooting tool, because what it allows you to do is you can put these watches out on your network, and then if something gets turned off or goes away, Fingbox will send you an email. So the number one problem, the number one thing that we get is, you know, why didn't my server email me and tell me that it died? And you think about that for a second, and you go, wait, what? Because it can't. That's like you telling the funeral director that you died, and you want the oak coffin, not the mahogany one. It doesn't work. So you need additional monitoring utilities on your network to be able to tell you when there's something that's gone wrong. And there's a lot of other options out there beside Fing, for Fing and Fingbox, for example, that you can use. Traceroute, or MTR. And what this does is this shows you the hops between various locations. Actually, we'll do MTR. Dyslexia wins again.
Quick poll, how many people in this room troubleshoot their own networks? And how many people have somebody do it for them? just checking how useful this information is. Thank you.
So what MTR does is it shows you the hops basically between here, my laptop, and this is actually a server that I'm running at my house right now. So there's 8 hops. This is actually pretty good. I wasn't expecting only 8. So there's 8 hops from my laptop to the server at my house. So if I'm trying to get from here to there, it has to hit all of these servers or switches basically in between. And what this is really, really useful for is figuring out whether or not there's a bad link somewhere on the internet. So the internet is this vast collection of mess. And it's all of these networks, and there's all of these peering agreements, and there's all of this other stuff that's really just important, but the bane of my existence. And let's say, so this actually happened this past week. Level 3 Communications had a major outage on the East Coast. They had a network switch, a fiber network switch, die in New York City. And what happened was anybody on Time Warner, Cablevision, or trying to get from Verizon back to a Charter network or anything like that, all passed through this data switch. And it goes away. So all of a sudden, you could do one of these and it would just stop. And you wouldn't be able to go any further. It's never actually going to make it all the way back. So in this case here, you can see we're leaving. I've got a couple of AT&T hops. I think these 12 addresses, this is a level 3 hop. and then I basically end up back to my home network on Verizon Fios. So it's a great utility for troubleshooting, can I get there from here? And yes?
So which one on that list is you?
I'm here, I'm the start, and then I've got all of these servers basically in between, and then this last one here, this 173.168.0.172, is a server at my house. And by the same token, I can also, I could, instead of tracing to a server, I could trace to Google. And you can see there's 9 hops from here to Google.
Let me interject real quick what this is useful for. I use it a lot. I use traceroutes a lot in our INET configuration. So if you have an INET, and we are now IP over our INET, and so there are several hops within that IP, or within that INET network. So if I need to find out if a switch is down or if there's a problem at a destination, I run a trace route between the route that I want, that I'm at, and where I want to go to, and that'll tell me. And I know the IP addresses of each switch inside my INET. And so if there's a switch down, like my core switch, for example, that's at City of Gilroy, then I know, oh, that switch is down, my entire network is going to be ruined, So that's what that's used for.
And one more tool that's pretty good is a tool called Wireshark. And what Wireshark does is, this is another application. This does essentially the same thing as a TCP dump, where what I can actually do.
What's a TCP dump?
I'm getting
What's a TCP? Sorry.
What this allows me to do is actually monitor all of the packets that are coming back and forth across my laptop. And you can see, I'm just pulling these up, and you've got DNS requests, and this is my laptop just sitting here. I'm not even browsing, and these are all of the various packets and requests that are coming in and basically saying, okay, who's where, what's going on, I need to route this piece of data to that, what time is it? And you can actually watch your machine or your laptop or anything actually give you the information that's coming across its network interface card. So if I start downloading something, you would actually see a whole series of packets basically coming streaming in. So in Wireshark, you can actually look at, and this is just totally useless for you guys, but really, really cool. You can actually look at, there we go, slide. It gives you a little bit of information about the packet, but it also gives you the hexadecimal bit code. It gives you the actual data that got transferred at the bit level. So not that you'd be doing troubleshooting at that level, but it's a very, very powerful tool for being able to look at something and say, okay, what's going on here? Especially when you're troubleshooting IPTV networks and you want to follow a stream, or you're looking for something and you want to extract that piece of information. Is that stream actually coming in here? Wireshark is a great utility for that.
When packet loss is a problem for you, I had my first network that I did with a Telvue system. We were having about 20 to 30% packet loss for some reason, and it turned out to be the throughput on the switch that I installed. But 20 to 30% packet loss on an IP video network can be a huge, huge problem. It can mean all kinds of very weird problems with your supposedly crystal clear playout. So,
thanks, Nick. And then the last thing that I just wanted to say, and this sort of goes back a little bit to documentation, is contact numbers. If you're buying support or you're buying turnkey equipment, it's going to come with support numbers. And having all of these again in one location, maybe a text document that you could use in the Dropbox assembly that you could set up, or in Google Docs, so that if there is a problem, you can very quickly find that number for Comcast Business Class and get on the phone with them. And the ability to get to that level is, without having to fumble through the internet and try and find something, is good.
Especially when your internet's not working.
Especially when the internet's not working.
Well, thank you for having me on the panel, honestly, guys. But so I have mostly more kind of general troubleshooting things. I was focused a little bit more, not so much on the IP side of things. So some suggestions I have as far as making troubleshooting easier for you. I would say to always try to test the easiest thing first. So, this is silly things like, is it plugged in? Have you rebooted it? And my favorite, and this is a term we use at my station, we call it impact modulation. I've also heard kinetic realignment.
Collapsing the wave function.
There you go. Basically, slug it. You know, I'm not advocating this with your playout server necessarily, but I've had so many live shoots where we're about to go on air and the monitor the talent's using is not working and they're freaking out about it. You walk up there, you give it a good smack, we're frightened. So before you start tearing everything apart, rewiring everything, I usually hit it at least once. So your mileage may vary on that one. There's a saying in the medical profession, which is that if you hear hoofbeats, think horses, not zebras. I think that holds true in troubleshooting as well. I know myself, I've done it a million times where I have some problem, and the first thing I think is, oh, it has to be this crazy thing, this crazy exotic problem that no one has ever seen before, and then it turns out, it's a bad cable. So that one stung me a million times. Kind of along the same lines, don't assume anything works. Chris had a good point earlier about cables in fixed installations usually aren't the problem, but I think we've all seen times where they are.
Yeah, sure.
Especially if, in my situation, we use a lot of students to make the cables and things like that. So it's not hard for a 7th grader to make a PNC cable that doesn't work. So I agree, test the things that are more likely to fail first, but, I've seen a million cables go bad that shouldn't have. One of the things that Nick mentioned early on is, kind of working along the line from the source to the destination or vice versa. I've found one of the things that I like to do, especially if you've got like a more complicated system, if you've got a camera going into a converter, into a switcher, you're testing 30 different things, it's nice to start in the middle instead of starting at one end and working your way all the way to the other end. If you start in the middle now, if it works there, you've eliminated half of those troubleshooting steps. You don't need to start all the way at the beginning. And similarly, if you've got 40 different things along that signal path, check the 20th one. If it works there, check the 30th one and go that way instead of going one at a time. Obviously, if you've got a camera going into a switcher and it doesn't work, you probably don't need to divide it up that way. One of the other really obvious ones that people miss all the time is to make sure your test equipment works. If you've got a cable tester, make sure it's got working batteries in it. And make sure it works. I mean, at our station, we had a cable tester that just had an intermittent solder joint on one of the connectors, and there had to have been 70 XLR cables that were marked, yeah, pin 2 doesn't work. And finally after, resoldering all these, somebody was like, hey, wait a minute, I just fixed this, and it still doesn't work. We realized, oh, it's a cable tester. So I try to just periodically, once every couple of months, just go back to the shop, find a working cable, just check everything, make sure that all works. And once a year I find something that's broken and silly. And along those lines too, in your shop, or it depends what you have for engineering staff, things like that. But I try to keep working examples of things. So I have a headset that lives in the shop and it never goes anywhere else. So when somebody gives me an intercom belt pack that doesn't work, I can grab my headset, plug it in, I know it works. Because it never goes to the chutes and gets dropped and things like that. So, along those lines, don't be afraid to swap things around. In our studio, we've got 3 cameras, they're all multi-core. Somebody will come in and they'll say, hey, camera 2's not working. I say, what have you tried to do troubleshooting? And they say, well, I don't know. I turned it off and back on, it still doesn't work. And I've told them a million times, like, okay, well, unplug camera 1, plug it into camera 2's cable. Does it work now? If it does, then now you can troubleshoot it that way. Instead of just looking at it and saying, like, it doesn't work, I don't know what to do. Especially if you're troubleshooting a bigger project, I really recommend that you document the steps you've taken in the troubleshooting process. Because otherwise, what ends up happening is, this isn't working, I'm going to try this, I'm going to try that, I'm going to try this, I'm going to try this. Okay, that fixed it. The fourth thing I tried fixed it. But the third thing I did, I forgot to switch back, and now it's broken because of that. So there's been a million times where I've fixed one thing and broken 2 in the process. And then related to that is to document what you find. So if you do find something that's broken, a headset that's broken or something like that, put a big obvious note on it that says this headset doesn't work.
Painter's tape.
Yeah, or we usually use gaff tape in our station. Yeah. But at our station, the rule is that if it's not marked, it's not broken. So it's somebody comes in and says this headset doesn't work, and somebody goes, oh yeah, that wasn't working last week. That's on them. To not have marked that. So we expect that everything that's broken is marked with the date, the person's initials, and a description of the problem. And I mean, there have been so many shoots where people have gone, the same headset has gone out 4 times to different cameras, and every time it doesn't work. And it's like, okay, well, I don't know what people expected, but marking is just really important. And to kind of piggyback on what Chris was saying earlier about network utilities and things like that that you need to have or that you should be familiar with, there's some basic test equipment that you should have. One of the things that has been indispensable for me is there's a box from Whirlwind called a Q box. If you don't have one, you need to get one. It's basically an audio source and an audio monitor and a cable tester all built into one. So if you've got a microphone and you're not sure it's working, you plug the microphone into it, talk, do you hear yourself? Okay, the microphone works. If you've got an audio output from a mixer, you're not sure it's working, you can plug the Q box in there. They're $100, $150, and they'll absolutely save your life, especially in live production. And then obviously, a good quality cable tester is absolutely indispensable. And then the other thing that I would recommend is what I would call a portable video monitor and video source. I give you the air quotes on that because I don't really care how portable it is. I've done plenty of troubleshooting by lugging around a 21-inch CRT monitor, around the station. I know a lot of people who've bought them, Harris and Videotech and Tektronix and things make these little handheld scopes. For $10,000 you can get this great little scope, little monitor, HD SDI, and it fits in your pocket and it's great. If you're working in an NFL stadium and you got to run all around the building, that's really what you want. If you're in an access center with a 2,000 square foot building, it's not that big of a problem to haul a monitor around. So, and for a portable video source, more often than not for me, I use a DVD player. There's no reason, I don't need to spend $800 on a little test signal generator to check and see if the monitor's working or not. So that's basically what I had for, kind of quick and dirty tips. So.
Awesome. Well, so that's cool because we have about 15 minutes left in the session, and I wanted to kind of go around and see if there's anything at your stations that's sort of the bane of your existence right now. That you might want to ask some questions about how you might be able to troubleshoot. And then as Brandon was talking, I just realized one of the most important things that we sometimes forget is that when we're troubleshooting a problem, there should be more questions than there are assumptions. So, for example, sitting in this room, we could probably troubleshoot some problems. I mean, it's good to be able to, try things out, obviously, but you can ask questions. I do a lot of troubleshooting over the phone. So, for example, somebody calls me up and says, my computer's not working. Instead of diving right into it, the first thing I say in a question form, is it turned on? Which causes, and this seems really dumb, right? And I apologize that it seems dumb, but it's important. Because they look down and they go, oh, well, the light's not on. Usually that means it's not on. Could you try turning it on? On. It's on. So that was a question and it solved the problem. A lot of your troubleshooting is going to involve questions. When I call Chris and I say, I banged my head against this forever, he starts asking me questions. Did you do this? Is this happening? Have you verified this? Yes. Okay, we can try this. Let me get in there and try this. And usually when I call him, it's for something that he actually has to go into the back end of the software and deal with. Because before I call him, I make sure that it's on, and I've done everything I can do to troubleshoot the problem. And usually, probably 90% of the time, it's something you had to go into the back end and do. Because I've done those things and I've started with the questions. So maybe if somebody has a scenario out there that just bothers them a lot, we can shoot it around for a while and do sort of a troubleshooting process. Anybody? Go ahead.
I actually have a bit of advice. You said you just got a Telvue system, right? Okay. Well, one thing that happens on Kauai a lot is we get a lot of power outages. I don't know why. Apparently electricity is even on island time over there. So one thing that happens is when the power goes out, you have like a 5-minute window, right?
Yeah, give or take.
Yeah. Those systems, in my experience, don't like to be shut off just by, just shutting down.
Most servers
violently.
don't.
They don't. Yeah, servers in general, they don't like it. So if the power ever goes out on you, what you should do is immediately go over to the server and press the power button just once. It'll shut it down automatically and nicely. And you will avoid problems, because one thing that's happened to me a lot is that we have these power outages, the system gets shut down, and then when the power comes back on, we have a bitch of a time getting the system back running. The audio is not working, there's issues. And I think we actually did fry out an entire server.
You did,
Yes,
and we
did.
sent you a new one.
Yes, we did, and we got sent a new one. It wasn't our fault. We weren't.
Yeah.
We're not always there when it happens. So it does happen like that. But
Yeah, you know, servers as a whole don't like the rugs pulled out from
they don't
underneath them.
Yeah, exactly.
You know,
so
and
if you ever lose power, just remember to shut it down in that 5-minute window.
Windows will blue screen on you sometimes too when it tries to come back up, and we get hard drive block errors.
Yeah, that goes for any system. You know, and actually a lot of like UPS systems have monitoring software that you can install as well, where it will automatically shut down all the machines.
Expensive, yes, but yes,
There
they
actually
do.
are some free ones as well.
Okay.
There's one called Network UPS Tools, which is free. The problem with it is it's almost completely incomprehensible. So I set it up at my station, and then like a week later, they decided to shut everything off. Like, for no reason, the power didn't go out. I just like everything was off. So then I always use that one. I would say if you do, we should do what I didn't and read the manual, because
Yeah, reading manuals helps.
yeah, I set it up at like 3 o'clock in the morning on a Friday night or something like that, and didn't test it. So I learned my lesson on that.
There's another question.
Actually, it was a question for a scenario that you presented, which is, are those outages extended outages?
They usually last about half an hour. For some reason, we just have these little power outages from time to time, and it's just long enough to shut the server down finally. You know, and then we get the channel running again. So.
Has there been a consideration about, because you mentioned UPSs. Is that on the table?
Oh yeah, no, I mean, we have one versus usually it's just not quite, like it'll still shut it down, but it doesn't have quite enough juice to keep running while it happens. So
Yeah, you know.
if you get the opportunity, if you are there and the power goes out, just remember that it's a nice easy way to shut down the system if you just press the power button once.
Really?
Yeah, and it'll just automatically go through the shutdown process, and it'll nicely shut the system down so that you can start it back up when the power comes back.
That's on any computer, on your Dell desktop at home or anything like that. That's industry standard.
And the interesting thing about UPSs too is that, you know, if you want to be able to be up for, you know, a half hour, 45 minutes to an hour, depending on your load balance, that's going to be a big battery.
That's a big
UPS.
And they make them.
Yeah, they do make them, but just so you know, I just installed some APCs that time rating that they put on that battery, that's based on a 25 to 50% load. It's not, and those are bell curves, if they're bell, right? And so it's based on a 25 to 50% load. It's not based on the peak load that it takes to start it up.
I think it's only if there's a full moon.
And it's right. It's only if they're a full moon. So even though I spent, you know, $1,200 a UPS, I might get 10 to 15 minutes out of these things that say they're rated for you know, 40 minutes because I'm loaded at 75%.
One of the other things, if you live in an area that's got bad power, that's going to kill the back end of your UPS. So what I've done is instead of buying expensive UPSs, I buy a lot of little cheap ones because I can replace them. The battery for the expensive UPS will cost you hundreds of dollars, and when you buy one of those new batteries and you put it in your UPS and you see the little blinking light still going bad, you're going to wind up swearing a blue streak. So the idea of this centralization of UPS that's one option, and it's good if you have money, but it's not good from the standpoint of the distributed philosophy of power backup. That's another option.
Yeah, and consulting with local electricians as well, because I mean, there's some devices that you can put in place that will help maintain sine waves. You know, there's I'll never forget. I did a lot of events a while back, and I had a 250-foot extension cord run. Now it was a 10-gauge extension cord, which is a pretty substantial cord, but it was still a 250-foot run, and I was running a PA system off of it. And what happens with AB power amplifiers is that the power is dynamically pulled. So the louder the music, the more power it draws. So I had Christmas lights hanging in the tent and all that stuff, and I would actually watch, and every single time that there was a low bass note, you could watch the lights dim. And I would end up in what they call a power bungee. So when you run really, really long, and when you're doing remotes, this becomes incredibly important. When you run really, really long cables, what can happen is you end up in these power bungees where you have these swings from 120 volts to 90 and back to 120, and it's really, really bad for the equipment. Kind of fun, but really bad for the equipment. One other thing that I sort of wanted to relay out there is fixes that you put in place once you've effectively troubleshot something to a resolution. Fixes often become permanent. Almost always do they become permanent. Sometimes, I mean, if you're replacing a cable, that is the permanent cable. And if you don't tag it or label it, you don't necessarily know that that was installed on this date, or it runs from video server output 1 to router input 1, or this is my network cable 17, which connects my master control server to the network switch. So because fixes become permanent, bear that in mind when in remote situations, fixing it now is obviously important, but remembering to sort of go back and finalize it if it is something that is going to stay there for a long time. Audio things or audio problem solvers are notorious for this, where all of a sudden you've got like this direct box hanging off the back of the rack and it's wired into this compressor, and then you've got that compressor wired into that DA, but that DA has a hum, so you've got a ground lift, and before you know it, you've got this giant mess that you now have to troubleshoot what you troubleshot to fix a problem that may or may not currently exist.
One thing that I did that helped with that at PEC is I went and I bought pink XLR cables, BNC cables, and Cat5 cables, and I put like 10 of each of them in the truck, and they're in a box labeled for emergency fixes only. So the idea is if somebody needs to replace a cable in the rack, it's bright pink. I walk into the truck the next time and I say, what's that? Instead of it just being another cable, it's stretched between two things and blends in with all the others.
Here's an awesome access problem. I know that we're all going to start shaking our heads in just a second. So how many people have large adapter boxes in your station? Right? It has everything you can adapt everywhere, right? Okay, so this is my most favorite thing. You got an access producer and they decide, oh, I can't make this do that, or this cable is bad, so what I'm going to do is I'm going to take an XLR cable that I know works, and I'm going to put 4 or 5 barrels on it until I get to the proper gender of the proper connector that I'm supposed to have. The problem with that is, and I'm sure everybody knows this, but the problem with that is, every barrel that you add, you just added another problem into your chain. Okay? And so that's 4 different things you have to check on your cable tester before you know what the actual problem is. And so the better option, that's a fine fix. The better option is next time you need that cable, solder one. Just do it.
We had a volunteer who was affectionately known as Adapter Jim, because he solved any problem with adapters just as a matter of course, like for fun. He'd be like, I need a BNC cable, and he'd like just adapt it with 40 different adapters just to see if he could. I'd be like, hey, your show's not on here, and he'd be like, yeah, I'm working on it. Maybe you should just use a cable.
And keeping those adapters replenished, because often, I travel when I'm doing system installations with an entire adapter kit. Because occasionally you need to convert that BNC cable over to an RCA cable, or you end up with something very, very strange, and keeping the common adapters in stock.
Yeah.
They're only $1.37 a piece.
Yeah, monoprice.com.
Yes.
Source for all adapters.
Yeah.
Buy new instead of chunking the old ones into the adapter box.
Yeah.
So periodically, just going through. It's better than uncoiling, recoiling, and rewinding.
And along those lines, if you're installing, another little pet peeve of mine, if you're ever installing new equipment, buy the right rack screws and buy new rack screws.
Yeah.
And I drove Nick up the wall with this, because I kept, I'm just throwing rack screws away. What are you doing? I'm like, I have new rack screws.
Yeah. And it's awesome. It's a good idea. The other thing I wanted to say is, if you're not making cables every day, like Chris does, or we all do, sitting up here probably make cables every day. If you're not making cables every day, especially network cables or something like that, buy factory sealed ones. Go to Monoprice, literally for $6, what is it, like $3 a foot or something, or $1 a foot. You can get a 100-foot Cat 6 cable for $20, and it costs you less than it takes you to make it. And the problem is that you have to make it, then you have to test it, then you made it wrong, then you got to chop it off, use another connector. I mean, just think about all those things you have to do, and you could have spent $20 and you're done, and you don't have to worry about the problem again.
Going backwards to that, the planning stage, how, in order to keep it simple, one of the things a lot of people don't do because we can't find money, but it's redundancy. So if you want to create redundancy in your system, where are the best places to do that?
It's a good question. So I mean, redundancy obviously meaning that you're expecting something to fail. Or you want it to fail and fail in a manner that you've got something there that's on standby. I'd say, I mean, it depends obviously very heavily on what you have for a budget. We have some customers that call us and will say, we want a redundant system. And you take the quote that was for the single channel system and you multiply that times 2 and add 5%, and that's about the cost of a redundant system. And that's not necessarily always feasible. So there are places, obviously, within a system that you can either introduce redundancy or introduce the easy methods for getting something on the air. So having a distribution amplifier, or spare distribution amplifier even, is a great way that you can not necessarily introduce failover redundancy, but introduce the ability to very quickly say, okay, you know, I'm having this problem, I've got this DA, I can get my channels back on the air with a DVD player. And just having that sort of in standby mode. Yes, you still have to manually take care of it, but it helps.
And on that note, one of the things that I've started doing when I'm building systems now is I run everything through normalizing patch bags. So in our truck, all the sources come in, they go through a normalizing patch bag and normalizing the switcher, and then all the switcher outputs do that as well. So that in a pinch, the switcher breaks, I can say camera 1, program, and we're back on here. So.
And places that I've built redundancy in, number one, you want most of your equipment should have redundant power supplies. It should come with it already, but if it doesn't, you're probably buying something that's too cheap to be in your station in the first place.
Or you want to buy the redundant power supply.
Or you want to, yeah, there's some options you can do. So that's one thing. Always use redundant power supplies. Some people laugh at me because I use redundant switches. So like in my CMAP build, I have I think 3 switches. If one of them goes out, I can take everything that was in that switch, put it into another switch, and be on the same way, running through the same path. So my network won't go down because all those switches are trunked together and they're really providing redundancy. So Chris is a huge proponent of like the 52-port switch that costs me like $1 bazillion.
1,000.
But yeah. So it costs me $1,000, which is a lot for me, right? But I'll buy 2 of them because I want to be able to, just in case, be able to just swap that over. The other thing you can do on network-wise is run everything through a network patch panel, so that if you have that problem, you're not having to take the home run Cat5 cables and plug them into a different switch. You're using the patch bay to do that. And it's faster, easier, and the patch bay is labeled. The patch bay is labeled. Okay.
I was just going to ask, when you mentioned redundant power supplies, does this mean a power supply that's sitting on the side?
It means a number of different things. Yeah. So, I mean, generally speaking, when we talk about redundant power, we're talking about a server or another device that literally has 2 power supplies in the back. They're both plugged in. You want to plug them into different UPSs that are on different circuits.
Or even if you only have one UPS, do one into the UPS and one just into the wall, so if the UPS breaks, it stays on.
Right. Trying to diversify that. So literally, I mean, power supplies are the #1 thing that gets blown up in any server situation, aside from hard drives. That's a different problem. But basically being able to, you know, they're hot swap in the sense that if one dies, the other one will immediately pick up, and then because one died, the other one's going to start beeping. And there's nothing more annoying than the server sitting there going, oh my god, I lost a power supply.
30 of them going.
Yeah. So that's generally what we mean. However, you can start talking about things like cold spares. It's sort of like Nick's model, where if it's inexpensive enough that you can buy 2, buy 2. And leave one either plugged in and configured, ready to go, or configure it, unplug it, and leave it on the shelf. If you leave it on the shelf, you have to, you know, and it's a configurable unit, you obviously have to remember that you have to configure it accordingly. But having spare stuff on the shelf, like a spare hard drive for your server,
Or a spare power supply like too.
Yeah, or exactly. And there are switches that can have redundant power supplies in them. Those tend to be a little bit more expensive than some of the business class switches, but not as expensive as just buying 2 business class switches.
Right. And you're, you know, the thing that I'll say, and we do need to wrap up because we are at noon, and I don't want anybody to miss lunch, but identify your weakest links and hold cold spares for those. So one of my weakest links in my broadcast system is those stupid black magic analog converters, and I know that someday one of those is going to fry, and I'll be out of channel. So I have 2 or 3 backups, and so if one goes down, number one, that weakest link is the first thing I check. Number 2, I know that if that doesn't have lights on it, because it's happened to me before, it fried. I just need to grab another one, plug the same cables in, and back up on the air. So your cold spares should be your weakest link. If your weakest link is your most expensive piece of gear, that's a problem. Yeah.
There's a bigger problem there. And along those same lines, you know, I mean, having spare parts for stuff, you know, a spare CPU fan, you know, stuff happens, it breaks. You know, and being able to get yourself to the point where that process is now documented. So when things fail, like hard drives, the likelihood that you're going to lose another hard drive is pretty high. In systems, these same things will keep failing over and over. And so knowing where those are and documenting the either reboot procedures, the restart procedures, or having spare stuff to be able to get that back to a functional state, it's going to be the same 5 things every single time.
So we are over time. John, I want to get to you, but I just want to let everybody know that that if you want to leave, you can, but we're here and we can keep answering questions if you have them. But John, go for it.
The spares, the cold spares, are a great thing for your Christmas and July list. What happens if your director comes to you off budget cycle and says, you know what, we've got an extra X amount in the budget, or not under budget, we've got this amount of money to spare. You want to have a list of things that aren't eye-droppingly or jaw-droppingly expensive to be able to provide that redundancy.
Other questions? Anybody?
Comments, cheap shots?
Comments, cheap shots, anything. We'll take anything up here at this point.
Oh, and as soon as you guys are done with your evaluations, I'll quit.
One last point that I'd like to make, and this is me being selfish. Before you get on the phone and call your server company, or Comcast, or whomever, because the internet's broken or the server's black, do the sanity check it before you get on the phone, because otherwise you end up with one of us going, is it powered on? You know, so just even taking the first like 3 basic steps. You know, looking at, okay, well we're black on one cable system, but we're not black on the other. So instead of calling the cable system and freaking out, good story for you, I was working on upgrading a system, and the customer had an outage. There was an issue where a DA died as we were upgrading the system, and it happened on a Sunday afternoon at 9 a.m. Now the customer had my phone number, could call me, but instead of calling to figure out what was going on, he called Comcast, even though there was a signal on the other 2 cable providers. And so after 6 hours and Comcast shows up and charges them for the visit and all that stuff, I get this text message that says, we've been having problems since 9 a.m. And I'm like, okay, well, why didn't you call me at 9 a.m. when you realized what's going on, because we're doing work? So, you know, you can leverage it. It's this double-edged sword. Sanity check it, but then leverage the fact that you have a support option that might be able to very quickly rectify something for you.
Also, you know, this is a huge problem for some of us. You know, when you're calling your cable company, when you're calling your cable company and you're saying my channel's black.
So when
We're going to troubleshoot this.
when you're calling your cable company and telling them, you know, your channel's black, the first thing they're going to say is it's your fault. And so what I've learned to do is check my signal path all the way through, all the way up to them. Because that way, when they say it's your fault, I can say, really, ask me what you want to ask me. Are you sending signals to me? Well, yeah, I know I'm sending signals to you because I'm watching it right now. And if you don't know that, you shouldn't have called the cable company in the first place. So just make sure you have that air checking.